Okay, Prof, we shall start. Okay, ladies and gentlemen, Assalamu alaikum and a very good morning to all the audience and our lovely student from the main hall. Can you hear me from the main hall? If you can hear me, raise your hand maybe. Yeah, thank you so much. I hope my voice is crystal clear for today for these sessions. And also, in order to ensure the smoothness of the entire program, I really hope the audience, the main hall's audience, can give a full attention by to keep your phone silence, and you can start to take the notes accordingly. Before we further, let me introduce myself first. I'm a chemist, Dr. Hussein Haniba. I'm the one of the senior lecturer from UiTM Dengkil, our foundations. Of course, today we are very proud to have our invited speaker. We import our speaker from Sarawak straight away to Dengkil. We have our professor, Dr. Khong Heng Yen, Professor Dr. Khong Heng Yen. Am I right, Prof? Sorry if I
Khong
mispronounce.
Heng Yen.
Khong Heng Yen. Sorry, Prof.
Yes, it's okay.
So let me introduce you first with our audience because they might not some of them not really in this area or need to have a small introduction about you. So, the session today we are going to discuss about the organic chemistry. Of course, I'm sure that's a field of the Prof regarding on this. And Prof, I have go through your CV, a short CV. It is very outstanding achievement that you have go through for the years back, almost 30 years of teaching experience. That's an outstanding achievement in your career, I believe. Of course, you are professor in the chemistry field from Faculty of Applied Science, University Technology Mara, Sarawak branch. This is one of the thing. And of course, Prof has great interest in the traditional medicine plants used by the local community in Sarawak. So I would say it is based on a natural product chemistry, which is one of the main branch of the chemistry, which is under the category of organic chemistry for particular. And of course, you are currently supervising a 10 postgraduate student. Again, I would like to mention to all audience 10 postgraduate students. And it's a combination of a master and PhD. And Prof has been awarded with the Staff Excellence Service, state recognitions about the PB Meritorious Service Medal PPB in 2017, and a lot of other outstanding achievement, local and internationals. Because Prof, if I go through each of your achievement, I might take more than an hour to talk about it. And you are one of the member of Syarahan Research Foundation at India as a honorary expert in Asian China Education Culture, ACEC associations. I well know this ACEC as well. And of course, you are a guest speaker to several internationals, university in China, Thailand, Indonesia, and Cambodia. Those are the outstanding performance of your achievements. And last not least, of course, about your paper publications, Prof. You have more than 100 full paper publications. That is a very good achievement. More than 100 papers in the local and also national and international journals with the Scopus Index and also impact factor with the outstanding impact factors. And you also become the reviewer for many international journal and conference. That's again, Prof, you have a wonderful achievements in your career pathway. I believe our audience are very excited to know about your sharing knowledge for today's sessions, your experience maybe, or maybe a day life some experience you would like to share with our audience, so at least our student, our future scientists may get a better view about organic chemistry, especially in the field of interest, they accordingly. So, Prof, with a great honor, I would like to invite Prof for today's sessions.
Thank you very much, Dr. Chemist, Dr. Hussein. Yeah, thank you for your kind introductions. Yeah, as you mentioned that, I think I also just mentioned to you that I could be an excellent researcher, but not a good teacher. So I hope you wouldn't have too high expectation of me. And in fact, I was very busy, and I just don't have much preparation, frankly speaking, but I will do my best. I hope through my sharing, you will learn a little bit more, and I hope what I share later on, because during the break, I also have a few minutes video about the TVS interview me on one of the innovation product, as well as one of the short video clip about the exhibitions of my product. So in fact, tomorrow I'm going to Kuala Lumpur to take part in the ITEX 2023, one of the collaborative project with UNIMAS, my collaborator from the neighboring university. And also I was invited to be the keynote speaker at the China Pharmaceutical University on the 1st to 3rd of June, which is another few weeks times. Yeah. So that's why I'm quite busy and fully occupied. But if you want me to talk about my research work, I can talk throughout the whole day also, no problem.
Yeah.
So, yeah. So I think, shall we start or?
Yes,
Yeah.
Prof. We should
Okay.
start. Yeah.
Okay. So let's start our lectures. In fact, I do not expect such arrangement. I thought just a normal, ordinary online lectures.
You are our VIP, welcome guest.
Okay. Okay, so I use the lecture notes prepared by your lecturers, but I make it slightly more colorful instead of just a white color background. But I think that one is good for painting purpose lah.
Yes.
Okay, so today my turn will be touched on the one of the hydrocarbon, one of the homoloxily on the alkene. So before that, I would like to you to how to say, scan this QR code and try to answer the question. You will find out the question after you scan this QR code. Yeah.
So it's a pop-up
Yes.
quiz for the audience, Prof.
Yeah, it's a pop-up quiz. Yeah.
So just give them some time. Maybe they are scanned
Yeah,
at the
sure.
moment.
So I think for the young generation, usually whatever they do, they like to ask why. So that's why I also pose a question, why?
Yeah.
Why is alkene important for you to learn?
And then I think the audience are answering the questions accordingly as well, Prof.
Okay. So I try to see whether I can get it online or not. Yeah.
Okay, Prof.
Or your site, can you help to show the result? Like,
How's Prof?
let me copy and see whether possible.
Okay.
The hyperlink is not active.
Okay.
It's, yesterday I tried, it's okay, but I don't know.
Maybe the connections, internet connection.
Yeah, probably, yeah. But anyway, can log in, and I use my phone to log in to check the answer.
Okay, Prof.
So the first who answer, you may get a diamond, I think, from the
Menti.
yeah. So is all have answered on?
I think basically they have answers, Prof, because I noticed they are
Oh, okay.
very calm down on the moment.
Oh, okay.
Yeah.
I think
And
have
also,
some, yeah, I think have some problem with the one. Okay,
okay.
but anyway,
Mhm.
later I can check for my my own file. I will get who will be the first one, and then
Mhm.
I will post you a special souvenir from Manet from Sarawak.
That's
Okay,
good.
probably yeah, I will send probably 3 and including to lecturers lah. So
Yeah.
later I will pass to Dr. Hussein and then
Yeah.
hope you can help to give to the students.
Sure.
Okay, so I'm not sure, I couldn't see the answer, so sorry about that. So I just wonder, probably if anyone can mention 1 or 2 answer, Dr. Hussein, what did the answer that you see on the screen?
Uh, I can see an answer, Prof. I just can see your
Oh,
QR code.
it's supposed to be displayed. Okay, never mind. Okay.
Okay, Prof.
Okay. So, but basically,
Uh-huh.
the importance of the study this alkane or, I think this one got some, or the title, the title haven't changed. Sorry about that. But today we only discuss on the alkane. So alkane actually, all the hydro is one of the hydrocarbon. So they are very important actually in our daily life. So for example, the plastic or whatever utensil that you use in plastic form. It could be especially this polyethylene, right? So it could be one of the product. And also in our body, in all the leaf, whatever also contains of carbon. That is the reason why we need to study hydrocarbon. So one of the homolog series in the hydrocarbon is the alkene. So today we will focus on just a few objectives. So basically you will learn how to name any molecule related to alkene group. You have to know how to draw the structure and also to name according IUPAC system. So on top of that, we will also learn a little bit on the rules, which is the Markovnikov rules, and explain the mechanism of the electrophilic addition of the alkene. So, and then at the end of this lecture, you are expected to predict what are the product, main product or minor product of the reaction given to you lah, related to the oxidation of alkene. So I just want to share one of the achievement because we have the knowledge of the basic chemistry, so we can do a lot of things, including innovative product. So this is one of the work that we had done by one of the PhD student. We synthesize it. Initially, we're trying to isolate the active compound from the plant, but we couldn't get the very strong activity. So therefore, we do some synthesis work, semi-synthesis work. We use the major compound, we derivatize it and add some functional group, make it very active biologically. So therefore, we have about 21 synthesized compound together with another few group lecturers from Puncak Alam and also IOS, FSG. So we have patent about more than 100 compound under the patent of an anti-inflammatory compound. Okay, so let's revise a little bit. I think you have studied in previous lectures about the saturated hydrocarbon, right? Okay. So for today, we are going to study on the unsaturated hydrocarbon. So what does it mean by unsaturated? So if you take note on the structure given here, you will notice a double bond here in between the carbon and carbon. So that is the difference distinguished between the alkane and the alkene. So when there is this, I think in the earlier form also, when you study about unsaturated solution, you also means that you can add on something to it. So later we will discuss on the reactions, how we can convert this alkene to another molecule. And because of this double bond, it also enable the conversion to any other product. Okay, start from the starting material of alkene. So and also if you, I think this one you also have learned earlier on about the structure, right? The geometric structure. So I think I do not need to explain further, right? This is the very basic one because you are from Asasi group. I believe all of you are the straight A student or very academic, top academic achiever. So I think do not need further explanation on this lah. Okay. So we just have a quick one, as we mentioned, that is the reason why we need to study the hydrocarbon. So you can, from the notes here already stated here, for example, ethylene is a natural plant hormone and used in the agriculture to force the ripening of fruits. Okay, beside that is also like to make plastic like polyethylene. So, and we can see actually in our daily life, we use a lot of hydrocarbon, involve a lot of hydrocarbon molecule, and therefore it's good for us to know a little bit and understanding the structure, the mechanism, why does it happen, and so on, right? So that is what the youth like to ask. Everything must ask why. I still remember when my girl was young, she likes to ask me, Mommy, why I need to do homework? Okay, he said, I already know. Why should I need to do homework? Especially the teacher like to give a lot of mathematics question. Same with you also. Probably you will ask your lecturer, why should I do the tutorial? Right? Do they have tutorial class?
Yes, Prof. They do have a
Oh,
tutorial weekly.
okay, they do have. So probably you may ask, I already know, why should I do the tutorial?
Yeah.
So, okay. So more practice will make perfect lah. Okay. So, and then the other part on the cyclohexanes, so they are the different form. You can have seen from here, they are involved 3 carbon, 4 carbon, 5 carbon, or 6 carbon. So therefore, the shape of the cyclone will be slightly different. Some look like a triangle, some look like the hexagon, okay? So that is the different form of the structures of alkenes. And in the earlier, I think you have also learned the homolog series about alkane and alkene. So in general, you can see the difference will be the A and E. You just change to E and E in terms of the naming, okay? So it's a very simple one, straightforward. So, but because this is how to say, is the standard one, so we will look at more slightly complex in the sense, just not really deep complex, but it's just a slightly extension to the main family members, okay, of alkene. So now we will go to the straight change alkene first. So first, I think you also learned in alkane earlier in the previous lectures, right? So what you need to do, you have to identify the longest change. So which one is the longer change for alkene? There is additional some sort like rules. You have to find the longer change that must involve or contain the double bond. Okay, so for example, here you can see on the left-hand side, the red color one. So you can see from here the H Okay, 1, 2, 3, 4, 5. So which involve the double bond. The other one, although you have the blue color one, there is a longer chain, 1, 2, 3, 4, 5, 6. Although there is a 6, but it doesn't involve the double bond. Therefore, we cannot say the molecule that contains 6 carbon is the longest one. Okay, so the longest change must involve the double bond. So therefore, the pentene, the 5 carbon would be the correct one, not the 6 carbon. Okay, so we cannot name it as hexane, but it's pentene involve 5 carbon as only. So let's look at more others molecule to understand better. So the first step after you've chosen the longest chain, later on you have to know how to name it. So then you have to try to numbers the carbon atom first. Okay. So how to name which position to start first? Left to right, right to left, or top to bottom, and so on, or top to the right, or top to the left. So it depends how different molecule, they have a different arrangement. So let's see the first one. Okay, so the first one, you can see the naming like from the left to the right, so also 6 carbon, and the other one on the right hand side one, from the right to the left, also 6 carbon. So you will notice that there is one like extra methyl group at the carbon number 5 if you name from the left to the right. But however, when you name the structure from left to the right, the methyl group is attached to carbon number 2. So therefore, we always have to choose the lowest numbers. The lowest numbers, just like when you are in the secondary school, right? When you sit for exam, you always look for the lowest number position in the class, right? You don't look for the highest numbers position in the class, okay? So that is how we determine the naming the structure. So let's see another molecule. So in the next one, bottom of the left slide here, you can see there are 8 carbon, okay? Beside the 8 carbon as the longest change, but you will notice that there are 2 some sort like additional group, the alkyl group, which is involve ethyl, 2 carbon, another one methyl, okay, 1 carbon. So you have additional 2 group here. So if you name from the left to the right, the methyl group will be attached to carbon number 2. The ethyl group will attach at the carbon number 6. However, when you name the molecule, the longest chain from the left, from the right to the left, then the ethyl group will attach to the carbon number 3, and the methyl group will attach at the carbon number 7. So when you total out the number, 2 plus 6 is 8, and the other one is 3 plus 7 is 10, right? So therefore, we always choose the lowest numbers in terms of the carbon number, the lowest. So therefore, we choose on the left-hand side. So which is we name the structure from left to the right, and we take methyl, 2 methyl, and 6 ethyl. Okay, so that is step number 2. So first step, we choose the longest chain. Second step, we try to give the position, the numbers, position to the carbon based on the lowest numbers of the carbon. The total numbers is the lowest. So let's see how we name this structure. So how to write a full structure? So in this case, we have 6 carbon is the longest change, and the methyl group attached to the carbon number 2. So we have 2 methyl. Okay, so for 6 carbon, how we name the 6 carbon? So we've got hex, right? Hex is means 6. So, and it involves 1 double bond there. So that's why you end with the E and E. So it becomes hexane. So then you have this double bond is located between carbon number 3 and carbon number 4. So with the rules of, we always take the lowest numbers carbon. So therefore we name as 3. Okay, we don't name as 4. So then the whole name of the full name of this structure, then we name as 2-methyl 3-hexene. Okay, so that is how we name the structures lah. So, and then another one, another examples, which just now we see the 8 carbon, involve the 8 carbon. So when there is a 8 carbon, then you know is we have to name as odd, right? OCT. So we add the E and E because it will involve the double bond. And then you have 2 methyl group, and because methyl is because of 1 carbon, ethyl because of 2 carbon, so therefore you have 6 ethyl. So should you name 6 ethyl first or 2 methyl first? Okay, so then we follow the alphabetical order. So E first followed by M. Okay, so that is why we name as 6 ethyl 2 methyl. So on the other hand, you can see here, if you have 7 carbon here, so 7 carbon, then you choose the smallest numbers of the total carbon. So if you name from left to the right, then you have 3 methyl, 6 6 methyl, 3 and 6. But if you name from the right to the left, then you have 2 and 5. So which is the total number will be slightly smaller. So therefore we take 2 and 5. But then because the methyl group, there are 2 similar groups. So then when there are 2, then we put di, di. If we have 3, then we put tri, tri. Okay, so if you have 4, then tetra. So therefore, we name as 2,5 dimethyl 3-heptane because 7 carbon is hep. Okay, we add E and E because there is a double bond belongs to alkene group. So this is how we name the structures. So then how about those involved on the cyclone, which have the close ring here? So then it depends on the numbers of the carbon as well, okay? So we add the cyclone pentene because they involve 5 carbon here. And then we always take the lowest number. So the substitution, the CH3 here is attached to the 1 methyl. So we do not name as 5 methyl. We always take the lowest numbers for the carbon. So similarly, go for another molecule here. So the same thing also, you name it. So for example, you have 1 methyl group, 1 ethyl group. So if you, those with the double bond one, usually you will start with number 1. Okay, so the double bond always in carbon number 1 and 2. Okay, so carbon 1 and 2. So therefore, you have either, if you, and clockwise, then you have 2 methyl and 5 ethyl. Okay, but if you anti-clockwise, then you have 3 ethyl, 5 methyl, right? So which one should we go for? So we cannot use the anti-clockwise. Why? Because the double bond is between, how to say, is anti-clockwise because the double bond is here. Okay, either you named, if you start with here, 1 and 2 must involve the double bond. That's why in this case, like you have no choice lah. So it's more or less is fixed. Okay. So same with others as well. You can see from here, the double bond here, we always have to start with 1 and 2. Okay, let's try, see whether you can do it or not. So there are 6, probably to save time, probably you just try 1 or 2, right? So later you can check whether you get it correct or not. Probably you ABC, you try 1 out of ABC here, 3 you try 1, and then D, E, F you try 1. See whether you can do a slightly different structures. Okay, one involve the ring, the other one doesn't involve the ring.
So they are trying, Prof. Just give me them some time.
Sure, yeah.
Prof, just now, one of my friends mentions about the quiz, then scan the QR code. Am I right? The friends told me that you need to activate the code before they really can try.
Is it? Oh, okay. Let me check again.
Because just now the student have tried, they cannot
Ah.
answer the question because it's not active.
Oh, not activate. Okay.
Yeah, Prof.
Probably because yesterday I created by myself. I tried.
Uh-uh.
It works. Okay, so sorry about that.
It's
Later,
okay.
yeah.
And also, those are in the main hall, our student. If you have a question,
Yeah,
please feel free to move forward and ask Prof. This is a very good opportunity to talk with the expert that from the area, the research area stuff.
yeah. I just do my best to answer lah. Yeah. And actually, this is my first time to give lecture to so many students, in terms of students.
Yeah.
Yeah, in terms of conference, yes, I do. I do present it to a big crowd, but mainly on my research area, but not lecture. I think throughout my 27 years in UiTM,
Uh-huh.
because branch campus, our class is very small. We don't
Yes.
teach a large group like this. We only teach the maximum. So far in my life, I think 40 or 42 is the max.
This is a very common situation for our foundation student, Prof. Somehow.
Yeah. So it reminds me back in my more than 30 years in my varsity time.
That's a very good.
Yeah, we have to rush, and usually what I do is I will sit in front, the first row.
Yeah.
I never hide myself behind the behind row one. Usually I will sit in front, the very first row, so that I can have direct conversation with the lecturers. Yeah.
Yeah, that's a very good. When you graduated for your first degree, Prof?
Yeah, UPM. Last time,
Okay,
yeah,
that's
last
very
time
good.
known as University Pertanian
Pertanian.
Malaysia. So
Exactly, Prof.
later change it to Putra. Yeah.
Yeah. Because then I think the student had a mindset when they heard the word of a Pertanian or agriculture, they have oh, okay, I'm the one to go here. That might be
Yeah.
the reason as
Yeah,
well,
I
Prof.
was the first batch of industrial chemistry,
Oh,
degree in
okay.
industrial chemistry. Actually, my first degree is industrial chemistry. First
Okay.
batch from a graduate from UPM. Yeah.
Hmm.
Yeah. I've been to almost all the university. I could say that the previous because
Mhm.
during my time we only have 5 or 6 university. Uh,
Yeah. The rest
the
is
o- consider
your
yeah
college.
consider the older university in Malaysia. I've been all. Yeah,
That's good
yeah. My
experience,
first
Prof.
degree is UPM. My
Mm-hmm.
master is UTM.
Mm-hmm.
My diploma in education, postgrad diploma in education in MU. So that's because a requirement to become a school teachers. So I
Yes.
was in the school teacher for 3 years. Then after that,
Oh,
I got an opportunity to join UiTM. That time was still known as ITM.
yes. Institute.
So yeah, so after that, I pursue my PhD in UKM. So
Mm.
and then I'm lecturer in UiTM. So I've been almost all the university.
That's good. And
Yeah.
I'm also glad of my PhD also from UKM as well, Prof.
Okay. Under which lecturers?
I'm actually Prof Azizan. I'm doing on battery research.
Okay.
Yeah.
I see. Battery, is it?
Battery, secondary rechargeable battery. More to the theoretical
Ah,
chemistry. Uh,
okay. Probably I talk to you more on that because actually, Sarawak Energy
uh-huh.
also looking for experts to trying to solve the solar panel. They have this
Okay.
battery issue. They want to dispose. disposal, and we see how we can recycle the material inside. Yeah.
Understood. I definitely will contact you after this, Prof.
Okay. Okay. Yeah.
So I think
So
I think we
okay.
enough time for them. We can
Yeah.
maybe yeah give answers.
Yeah. I can just show you the answer.
Yes.
So yeah. Anyone need explain further on this?
Yeah. Maybe the student have a questions, or maybe you can
Yeah.
raise the hands over
Yes.
there to hint our prof.
I cannot see the. Let me change the setting, I think.
Mhm.
Okay.
Maybe the lecturers in the main halls can, if there is a questions, you can represent the students and move forward to ask the question the student might wondering. Because sometimes, Prof, it is always our Malaysian culture maybe a bit shy to ask the questions, or maybe that's the reason. Our lecturer is there as well.
Yeah, that's why it made me so nervous.
No, Prof. We
That's
also
why I
learning
said
from
I
you.
said I never expect. I thought just an ordinary online lectures. I just interact with the students. So
It's okay, Prof. Definitely they are guiding the student as well. If
uh,
they have questions, maybe I can see a few lecturers of my friends over there.
okay. How many of them actually exactly?
In the main hall is 300 students around.
Oh, okay.
For Asia, any question for Asia?
Probably they have question out of the lecture question.
Yeah.
Mm.
Wait, I think for Asia is coming. I think they are understood the question.
Yeah,
Maybe, yeah.
yeah, I think so.
We
Yeah,
don't
I
have
think
any questions.
Pardon?
yeah, good. Yeah, sure.
Okay.
No question.
Okay,
Because
that's
they
good.
are all well taught by all of you. Yeah. So
Thank you. So we are, Prof. We might excited to go for the next part as well, Prof.
yeah, sure. Okay, let's move on. This one is the other way around. So if you are given the name, you have to draw the structures. So probably also the student can try just one. Yeah, see whether you can get it right or not. Later I'll show you the answers. Yeah. So when you
Maybe.
draw, yeah,
Uh-huh.
when you do the drawing the structure, you always start from the last one, the main
Yes.
skeleton. Okay.
Mhm.
You start with the last one. So for example, here you got HEP, so you know it's 7 carbon. So you just draw 7 carbon first, the 7C connect to each other first. And then after that, you see there is a 3 there. So it means that the double bond is
Double bond.
between 3 and 4. Okay, you will place the double bond between the carbon 3 and carbon 4. So later on, you check. Okay, on the left hand side, you have what? Methyl. 2 methyl. How do you know it's 2 methyl? Because di means
Mhm.
2. So then at which position? Carbon 2 and 2. So you got one methyl up at the carbon attached to carbon 2, another methyl group. Probably you can draw at the bottom there and attach to carbon number 2 as well. That is how you draw the structures lah. And you have ethyl group. So ethyl means you have 2 carbons. So it's C2 H5, or you can break into CH2 CH3 also can, right? Attached to carbon number 3. So
Prof, if you don't
yeah.
mind, let me ask a question as well. If
Mm,
this kind of questions, when they ask us
mm,
to draw the structure,
mm.
maybe student wondering, are they allowed to draw the expanded structure or skeletal structure? Or in your opinion, which will be the best?
Um, But actually, if we depends on how the question asks, he said draw the structure. So they
Yes.
do not specify must be a geometric structure,
Mm-hmm.
what type of structure. But as long as you can show
Mm-hmm.
the the arrangement. Mainly they want to see, to test the understanding of the student. But of course, you cannot just put C dash C without, that is called half semi-structure. So it's not full
Yes.
structure. So at least you have to show, you cannot just give me like C dash C, but I do not know how many hydrogen is attached to the C there. So at least you can show, although you do not draw the full structure. For example, you do not show the carbon C, you have 3 single bond attached to the proton, is fine to me, as long as you can at least write CH3, So it depends on the questions lah. If the question specifies, say, draw full structure, then
Okay.
you still give half of the structure, then it's not right lah, to me lah. Yeah.
Okay, Prof.
Usually if follow the SPM marking scheme, it do not, how to say, you couldn't get full marks. You are expected to draw the full structure, because the reason they ask you to draw, they want to test your understanding, whether you know how does the full structure look like.
Because what I'm wondering is over there, is that will be good if we draw the full structure, the expanded structure, because some of the researcher or some of the lecturer, they might ask us to encourage to draw the full structure, because definitely this going to be continuous for another question, which is mostly interrelated with the mechanism of the reaction itself.
Correct. Yes, you are right. So that is why I say usually the question asks you to draw. Actually, they're trying to check whether you understand the structure, the full structure. How does the full structure look like? That is the intention. So therefore, we expect the student to draw the full structure.
Sure, Prof.
Yeah. But if, of course, how to say, it depends on the examiner interpretations lah. So if, let's say, if this question, if the student do not draw the full structure, but from the answer, I could understand that actually the candidate understand how does the full structure look like. So I will also give full mark lah, unless the marking scheme say must be full structure, only get full mark, then no choice lah. So only give half of the mark. Yeah.
Okay, Prof. Sure. I think our audience also done. So we can maybe we can proceed to the next slide as well, Prof.
Yeah.
Oh,
So
that's
this is the structures. Yeah.
just one concern, Prof, regarding the structure of the A and the B itself, Prof. Is that is that accurate, or if the student doesn't follow? Because this is a very common question during the class hour. The pattern, the angle, if they have a slightly different angle or different position, it is still counted. Is not an issue. Am I right, Prof?
Yeah. To me, it's not an issue as long as they indicate at the right position. Yeah.
Okay, Prof.
Because the structure, how do you draw it? Probably you turn the other side round, another 40, 90 degree,
Yes.
or another 180 degree is okay to me actually. As long as the structure reflects the name given, yeah. Or the name given is reflect the actual structure.
Okay,
Either
Prof.
way, yeah.
Clear. I'm very clear. Okay, Prof. We just asked the one in the main hall. Any questions regarding the structure?
Yeah, but I think for this type of question, I think usually in a tutorial class, a smaller group, they may be more bold to ask question. If a large crowd like this, probably they not there to ask question. But probably you can ask them to give a hand wave whether they understand or not understand.
Yeah. How about our main audience, main hall's audience? Are you clear? Yeah, it will take some time to reply as well.
Yeah.
If you are clear, can you wave, Prof? Maybe raise your hand. Okay, that's clear. Very good, Prof. Very good.
Okay,
Very
good.
good response.
Yeah, very good. Yeah. Usually good students are more active. Yeah.
Yeah, definitely, Prof.
Okay, so just take a break. I let you listen to one of the innovation product that we have this signing ceremony. Yeah, can hear not?
No, Prof.
Hopefully.
Maybe, Prof, you need to
Huh?
share the audio.
Oh, have to change the audio.
Yeah, share audio as well. When you press the sharing button, you need to
Uh-huh.
put the audio as well. Press the keyword the key box over there. Mention share audio.
Share audio. Huh? Then I have to go back to the.
When we put the share,
Cannot hear her like this.
cannot, Prof.
Okay, hold on. I end the one first.
But do you notice on a Prof when you press the share button, it pop up with something like share content. Do you notice on the top there is put it on the word share the computer audio?
Okay, hold on. I let me open the
Mm-hmm.
because now the screen is very small. I don't know where.
Hmm.
I don't know what happened to this screen. I cannot see at all the button.
Maybe, Prof, stop sharing at the moment.
Yeah, that's why I couldn't find the button.
Oh, then when we press the button over there, the WebEx buttons, there is a icon share, am I right?
No, I don't know why my screen become very. Okay. Okay, I see the share and then
Do you notice or not? On the top of the icons over there, there is a button, a box, share computer audio.
share computer audience.
Audio, yeah.
Only share content.
Once you have put the screen and you
Uh,
over there, there is a share computer audio.
okay, okay,
Okay,
okay.
you
So
need
I
to
have to
take,
take. Okay,
yes.
okay, okay. Thanks.
I think now we might here.
Komuniti
Yes,
Sains
we can
Teknologi
hear.
dan Inovasi STI di Malaysia perlu meningkatkan interaksi dengan pemegang taruh bagi memberi keyakinan kepada pengguna terhadap produk inovasi negara.
Menteri di Jabatan Perdana Menteri Datuk Seri Nancy Shukri berkata persepsi dan mentaliti masyarakat Malaysia terhadap penggunaan produk tempatan baharu dan belum berjenama perlu diperbetul. Pendekatan dalam menjelaskan sesuatu produk kepada mereka yang tidak mempunyai latar belakang teknikal juga harus diperbaiki bagi mengurangkan perasaan was-was masyarakat. Tambahnya, bagi memastikan produk buatan setempat setaraf dengan produk luar negara, pengiktirafan dan akreditasi melalui pensijilan turut memainkan peranan penting bagi menggalakkan inovasi dalam kalangan usahawan. Datuk Seri Nancy berucap merasmikan program aspirasi 2050 di Universiti Teknologi Mara UiTM Kampus Syarahan di Kota Syarahan. Beliau kemudiannya menyaksikan majlis menandatangani perjanjian pengkomersialan produk inovasi UiTM bagi mengkomersialkan produk tepung pisang bebas gluten hasil inovasi unit penyelidikan UiTM menerusi syarikat Banana Tree Sendirian Berhad. Perjanjian ditandatangani oleh Rektor UiTM Profesor Datuk Dr. Jamil Hamali dan Ketua Pegawai Eksekutif Banana Tree Sendirian Berhad Toza Bing.
Komuniti Sains Teknologi dan Inovasi STI di Malaysia perlu meningkatkan
Yes.
interaksi dengan pemegang taruh bagi memberi keyakinan kepada pengguna terhadap produk inovasi negara.
Okay.
Yes.
Back to lectures.
Yeah.
So yeah. So the reason I show that is because I would like to encourage more students to participate in the innovations and inventions. So I think the students have to how to say, to be encouraged, to be motivated to how to convert even a waste to become something useful. Initially, I was actually trying to introduce my product, one of the the cosmetic product or nutraceutical product, by using the banana extract, because banana extract contain very high, very strong antimicrobial activities. So that is how we can use our knowledge to make something useful lah for our communities. So that is the reason why I share. So we can that product was turned out come out with this is because the company want me to solve their problem, because they are the banana chips manufacturers. So they have a lot of waste of the banana peels waste, talking about tons, many tons a week. So they have this issue of disposal of these banana peels. So therefore, from the basic information, the nutrition profile, I convert it to become something gluten-free flour, which is a niche product to those who have do not have any gluten tolerance patients lah. So, and also actually you will be surprised, the banana peel contain 2 times protein than the flesh. Okay, so from our result sent by conducted by the independent laboratory outside, let's say the fresh is about 5.6% of the protein, but the peel content of 11.2%. So that is very interesting. And also, but we cannot eat the banana peel like this, right? The raw one. So that's why we convert into something flour, which we can use as an ingredient to make a lot of other food lah. Okay. So that is why we also the reason why we need to acquire some of the basic chemistry knowledge as well as other subject. Okay, we don't only focus on chemistry, but actually other sciences are very important. So I hope all the students will remain in the science or as science and technology based program after you completed your asasi lah. So the reason why is because Malaysia still need you, need many scientists or many professional in the S&T based program. So probably don't always think that if I don't pursue, other people will pursue. But the percentage is, how to say, is much, we are very far behind from our target, the 60%. So therefore, I hope all the students will continue to pursue in S&T based program. Okay, so okay. So now we continue. After we know the structures, we know about a little bit on the naming. So now we move on to the preparation. How can we prepare the alkenes from the other starting material? Okay, for example, here we have the alkane halide and how we can eliminate the Cl, okay, and become alkane. So what we can do is we can undergo these reactions. Okay, so for example, we have this using the potassium hydroxide. So then you can see the reaction. One of the product, the main product is the main product is the ethene. Okay, and so similarly, we also can use the starting material from alcohol. If you want to have ethene, so you choose an alcohol with the 2 carbon as well, which is ethanol. So, and by performing under the heat with using the concentrated hydroxide, sulfuric hydroxide. So you will also manage to prepare the ethene. So in other words, actually, there are many ways lah, okay, to prepare the alkene. So same thing also in our life also, there are many ways to achieve our dreams, okay? Some people take a longer path, some people taking the shorter path. Okay, so whatever it is, as long as you persistent, determined, you will achieve your goal. Okay, so just like me, also I never dreamed to be a professor. I just work hard and work whatever I need to do. So when there is an opportunity, I just apply for the professorship, and I thank UiTM also given me the opportunity lah to be promoted to become a professor. Okay, so when we talk about this, the reaction, probably we want to understand a little bit more and how does this can be happen also. So for example, this electrophilic addition reactions of the alkene. So from the short notes given here is addition reaction is the reaction where the saturated molecule and become saturated by the addition of a molecule across a double bond. So earlier on, we mentioned that alkene is unsaturated hydrocarbon. So it can, how to say, do a lot of wonders because of the double bond. It can convert, okay, into a saturated carbon or the single bond here. And you can substitute, okay, the H can be substituted or added into the molecule here. So it become another products, okay? So here also mentioned that the alkene are relative more reactive than the alkane because it is unsaturated, so you can do more things lah, okay? So just like our hand, if two of our hands are full with holding something, that's why we cannot have take extra thing on our hand also. So the similar phenomena as well. Okay, let's see. And for this addition reaction, we will discuss about, I think, 5 different reactions. Okay, the first one is about the hydrogenation. So the hydrogenation means you add the addition of hydrogen, so to the double bond. So when we break out the double bond here, so you can add another 2 because as you understand also in your early days, you study carbon is in group 4, right? You have 4 electron valence. So therefore, you want to achieve the octet, the state, so you have to have about 8 electron valence. Okay, so therefore, it could be able to add another hydrogen to the one of the carbon, and another carbon also can add another hydrogen. So it will turn out become ethene, become ethane. Okay, so and of course there is a condition apply in this reaction. You have to apply if you use the catalyst, okay, different catalyst, probably you need to apply different temperature. Okay, so here you have shown a few here. If platinum or the nickel, you will apply different temperature. So as I mentioned just now, there are many ways to produce the alkene, okay? So, and let's try, or already give it the answer here, okay? So this question also, probably you want to try it out, see where you're supposed to add the hydrogen, okay? It's quite a simple one. Probably you can complete within less than 1 minute for these 3. So you look up for the double bond. So where there is the double bond, then that means there can be added another hydrogen. Okay, I think shouldn't be any problem, right?
Yeah, this is
So,
quite straightforward. Yes,
yeah,
Prof.
this is very straightforward. Okay, so that is the how. And now we move on to another one we call halogenation. That means we add the either halogen like chlorine, bromine at the room. The condition is just at the room temperature and that condition. Okay, so you can see from this equation, the very direct forward also is where the double bond is. Then you can add the bromine. Okay, so you can probably the student may ask which how to say the bromine atom should draw in up, down or side, actually is the same lah, because this is just it's not the 3D structure. So so where you want to place the bromine, up or down or side is okay. Okay, so because it was still attached to carbon 1 and carbon 2. So then how about the other one we call halogenation in so this one it involves the water in the water. Okay, so in this case, so it will be have a slightly different, because as you know, water you have H2O, you have H and OH. So therefore the product will be slightly different if compared to the previous one. Okay, this one. Okay, in the inner solvent. So you can see for the inner solvent, it will still have two molecule, the bromine atom or any halogen atom there. But if for in water, then it could be slightly different the product, because due to the water molecule, it can break into H and OH. So therefore, you have a different product. But you can see from here, it will still attach one attached to carbon, one the other one to another carbon. It cannot be both attached to the same carbon, okay? Due to the electrovalence, you need to achieve the octet state.
Just wondering, Prof,
Yeah.
this one will be applicable for, I think, a molecule with the symmetric compound, isn't it, Prof?
Yeah, this one from here, yes. From here, the structure show, yes.
It's a symmetric. If it is not a symmetric product, then it's going to be a different approach as well. Am I right, Prof?
Yeah, there is later we will study another rules they can apply. Yeah,
Yes.
so we will look into it. We from the very simple one to slightly more complex one.
Okay.
Although in the rules there are actually 3 rules, but somehow we will later listen to one of the video also. See, it will guide you how to do the shortcut. You can forget about the rules that you study, the 3 rules that you study, and only focus on one about the stability. So later we will look into it. Yes. Okay. You can ignore the rules. So sometimes in our life also, we have many things to do, but we have to prioritize. Okay, the first important things to do only. So just like last time I also used to ask when I was young, but the elder people will tell me, okay, now you are a student, your main task is study, okay? You don't need to divert your focus on other things first. Your main job is study. You are asked to study. You come to campus, you come to university, the main reason is, of course, you have to develop your characters. On top of that, your main task is study. Okay, yeah. So another one, another example given here, okay, about the bromine in the water as well. You can see the same thing also. You have H and OH. So therefore, OH, the H will combine with another Br, and OH will combine attached to the carbon. Okay, so you may ask, why is it not the Br attached with OH? I'm not sure whether anyone want to ask this question or not. Why must be H attached with Br and not the OH attached with Br? So it become like the H attached to this carbon, Br attached to this carbon, and then you have another side product, HOBr. Okay. So probably you want to ask, you can ask your lecturer during the tutorial class if you
Yes.
want to know. Yeah.
A
Okay.
small
Yeah.
assignment for the lecturers as well.
Yeah, so I think the student, if the student acquires some basic knowledge like this delta, here actually is already clearly stated here lah. Okay, you have the delta negative, delta positive. You know, usually we have opposite sex are more attracted to each other. The same thing with the charges must be opposite charge. They only attracted to one another. Okay,
So it's
yeah.
basically due to the different electronegativity, Prof.
Yeah, the different charge, yeah, the
Yeah.
opposite charge, yeah.
Get it.
Mm. Okay, so this is another example. What if just like Dr. Hussein just now mentioned, what if you have a longer change, involve the longer molecule? So what will happen to this? So you can see from here you have carbon, right? You have carbon
Yes.
1 and carbon 2. So
Mhm.
usually it will still attach to those unsaturated one, because those already like this methyl group is already saturated, so
Yeah.
it cannot be added another one. If added another one, it will more than 8. Okay, the electron valence, the valency become more than 8, so which is beyond the how to say, the natural the nature rules. Okay, so it cannot be extraordinary unless you substitute, then possible. Okay, but not add into the first carbon here. So you can see from here, the OH and Br always attached to the double bond here because they still haven't saturated. They can be added another family members lah, we so called. Okay. So that is how we can predict the product. Okay.
Maybe also, Prof, in my it just would like to add on a bit.
Mm.
Maybe we can also highlight that the double bond, or due to the unsaturations, due to the presence of the pi bond over there as well. Am I right, Prof?
Yeah.
Yeah.
So yes.
Okay, Prof. I do understand.
Yeah. Okay. So let's try it out, see whether you can get this structure, the product, predict the product or not. It's actually quite direct forward also, right? You have one Br and one OH, right?
Mhm. So basically, the reactions will involve between the Br ion and also OH minus, and the
Yeah.
OH will attack the site, the carbon with the least number of hydrogen, isn't it, Prof?
Attached to the least numbers of the, you mean the OH or the Br?
The OH, maybe, Prof?
Okay, there is a rules saying that how to say, the rich become richer. So if you have rich in hydrogen, it will become more hydrogen, right? So richer
Okay.
in hydrogen. So that one we will explain a little bit later. Yeah.
Okay, Prof.
Yeah. So there is some people they put this statement say rich become richer. So usually the hydrogen will attach to those who already rich with hydrogen. That means more hydrogen. It will attach to that. Okay. But of course, there is also on certain circumstances, it does not really apply. So in what conditions? So that's why we say that this rule may not apply when we talk about another shortcut, how we can predict the product, because we based on the stability is more important, is
Okay, Prof.
priority. Yeah, yeah. Okay. So this is the predicted product. Okay. Okay. let's move on to another one. It's still fall under the hydrohalogenations. Okay. So, and this one probably I would like to show you one of the video clip later on, so that you can listen to other voices.
In the last video, we saw a potential mechanism where if we reacted hydrogen
Can see,
bromide
Anna?
with this alkene right over here, that we can essentially add
The video
the
doesn't appear. We can hear the sound,
this
Prof.
halide to
Oh,
what
cannot
it
hear,
was
cannot
started
see
as an
the screen.
alkene and then it ended up
Cannot see the video. Yeah.
as
Oh, cannot see the video. Okay.
bromopentane as an
Cannot see the video.
Yeah, Prof.
So that means I cannot show. Doesn't matter then. Should I?
Maybe, Prof. Again, the
Ah.
share. Again, the same icon. Share. I think you might have. Do you notice the YouTube icons over there, Prof?
YouTube icon.
Uh-huh.
You
You
mean the file or the what?
the file maybe, Prof. Share the
Okay, the
audio.
file.
Uh-huh.
The file.
Okay, Prof.
Okay, let's see. Share and then go to the file, is it?
Yes, Prof. That will be also nice. Yeah. Okay,
This
we can
one?
see now. Yes.
Okay. Is it small screen or big screen now?
It is a small
Small
screen.
screen.
Yes.
Small screen. How should I put it?
Yeah, that button, Prof.
Like this?
Yes, yes, Prof. We can see big now.
Okay.
alkane. But when we did that, we made a, I guess you could call it a somewhat arbitrary decision, or I didn't explain why we made the decision. We said, look, this hydrogen is going to be partially positive because this guy is so electronegative, and maybe when it's partially positive, it'll be attracted, maybe it'll just bump in just the right way into one of these carbons, it'll maybe swipe its electron. We somewhat arbitrarily in the last video decided that it would swipe this guy's electron, but you could just as easily imagine a world where it swipes an electron from this guy. So let's draw a mechanism for that and just think about which one is more likely to actually happen. So what happens? So once again, this guy, let me draw all of his valence electrons. So there's the bromine, 1, 2, 3, 4, 5, 6, 7 valence electrons. You have the hydrogen. I'll do it the same color. The hydrogen has its electron right there. This is partially positive and this is partially negative. The hydrogen might want to swipe one of these electrons away. Let's do it from this guy right here. Let's do it from this guy. So he has this electron right over here. So the other side of that bond, it goes to the hydrogen when the hydrogen goes near it, or maybe it's attracted to it. And when it goes to the hydrogen, then the hydrogen lets go of the electron that the bromine wanted all along because it's so electronegative. So then that electron goes to the bromine. So after we do that, what will it look like? What will be the next step in our reaction? And it will look fundamentally different than this right over here. So now what happens? So we have a carbon bonded to two hydrogens, and it only has a single bond to the other carbon, which is bonded to the original hydrogen right over there. The rest, let me write my hydrogens a little bit. Actually, let me write this whole thing a little bit neater. So you have your carbon bonded to a hydrogen and another hydrogen, and now it only has a single bond to this carbon right here, which is bonded to a hydrogen, and then the rest of the chain. Let me just draw the rest of the chain right here. And now this electron went to the hydrogen. The other electron that it was paired with is still with this carbon. So now this carbon is now bonded to that hydrogen over there. So this blue electron is now with the hydrogen. So let me draw. So the blue electron that was here is now gone over to the orange hydrogen. Has now gone over, let me draw a little bit neater than that. Has now gone over to this hydrogen right over there. And then the hydrogen lost its electron to the bromine. So the bromine originally had 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, and then it nabbed an extra electron from the hydrogen. So now it will have a negative charge. It is a negative ion. It is bromide. It's a bromide anion, I guess you could call it. And since this guy lost an electron, he had 4 valence electrons, lost one to the hydrogen, he now has a positive charge. He's a carbocation. He's a carbocation. And then from here, so notice the difference. Before, this guy lost the electron, and so the hydrogen bonded to this carbon. In this situation, this guy lost the electron, so the hydrogen bonded to the other carbon. And so you can imagine from here something very similar happens as what happened in the first video, but now it happens to this carbon right over there. So let's do that. This carbon is positive. The bromide ion is obviously negative, so maybe he'll want to swipe his electron away. So this electron then goes to the carbocation, and then it will form a bond. It will form a bond. This green one will go to the carbocation, and then this purple one still stays with the bromine, and so they'll have a bond. They're paired up, you can imagine it. So then we're left with, we have a carbon, we have our original hydrogens, we have this carbon, that hydrogen, the rest of the chain, CH2, CH3, and then you have this hydrogen right here that it bonded to. That was kind of our first step. And now the bromine has bonded to this carbon right over here. The bromine has bonded over to that carbon right over there. And we're done. This is another possible mechanism. This one we ended up with 2 bromopentane, right? Because it's on the number 2 carbon. Here we have 1 bromopentane. 1, 2, 3, 4, 5. Still 5 carbons. It's just the bromine is attached to the 1 carbon here, attached to the 2 carbon here. So we now need to think about, because, you know, at a first cut, these both seem like reasonable mechanisms. But if you did it experimentally, you would see that this is the one that you would really observe. I actually haven't done this exact experiment, so I don't know the proportions, but you're going to observe this one disproportionately. The great majority of the products that you see are going to be this one, not that one. And so the question is, well, you know, they both seem like reasonable things to do up here. Why is this one so much more likely to happen than that one? It all comes from something called Markovnikov's rule. Markovnikov's rule. Nikov's rule. And there's a couple of ways to think about it. And when Markovnikov thought it up, or he observed it, it seemed to work. They weren't 100% sure about why it worked, but we can even think a little bit about why it worked. So Markovnikov's rule, a couple of ways you could think about it. You could think of it as the thing that already has more hydrogens is more likely to get more hydrogens. So that's what happened here. This thing had more hydrogens on it than the right carbon right here. This right carbon had a hydrogen, but it had some other, I guess you'd call it an alkyl group attached to it. And so the thing that had more hydrogens ended up with the hydrogen, and then the thing that had more groups, this character right here had more groups, right? He had 1 group over here. This carbon over here had no groups. He ended up with the bromine. So the thing that has more hydrogens ends up with more hydrogens. The thing that has more groups ends up with more groups. So I guess you kind of go more in the direction that you were going in. But that still is just, you know, a rule. So, you know, why does that make sense? And it all makes sense, or it starts to make sense when you think about that in both mechanisms, we had to have a carbocation. Right? We talked about in the last video, carbocation. We had a carbocation right over there. This is the left carbon being a carbocation. This is the right carbon being a carbocation. And Markovnikov's rule is all comes from which carbocation is more stable, which one has a lower energy level. And it turns out that the carbocation that is bonded to more, I guess, electron-rich molecules or atoms is going to be more stable. You can imagine that it has more things that, look, it's positive, but it has more carbons around it, so it can share some of those electrons. You know, the electron clouds will help it out a little bit to be a little bit more stable. This one right here is only bonded to 1 other carbon, so not as much sharing. This is bonded to 2. So in general, when you're only bonded to one other carbon, you're called a primary carbon. And if you're a carbocation, this is a primary carbocation right here. This guy is bonded to 2 carbons, so he would be called a secondary carbon. Since it's a carbocation, it's a secondary carbocation. So this right here is secondary. Secondary. So a secondary carbocation is more stable than a primary, and actually a tertiary. If you had another carbon group here or something else that had a lot of electrons around it, that would be even more stable. So bonded to 3 things, more stable than 2 things. And when I say 2 things other than hydrogen, and then more stable than 1. So the Markov-Nikov's rule all is a byproduct of the fact that this carbocation is more stable than this one over here, and that's because it's secondary versus primary. Because it's secondary, it can kind of borrow electrons from some of its friends, has more neighbors to borrow electrons than this one. And since this is more stable, this is more likely to happen. This is a more likely intermediate to have. This is a less likely outcome to have in general. And that's why you're more likely to get to this left product, the 2-bromopentane, than the 1-bromopentane.
Okay, Prof.
Yeah, back to our lectures. Just now, I hope you can get what the presenter trying to share on the how does the Y2-bromo is more favor than the 1-bromo, okay? And also answer just now, Dr. Hussein answer also whether the H attached to the more. So, okay, so the general rule is the rich become richer lah. So if the hydrogen, you have already rich with hydrogen, so you become richer hydrogen because the H will attach to those carbon with the more hydrogen rather than to the group. Okay, so the Br will attach to those who have the group because of the carbon actually carbon ion, the primary and also the secondary. So later on we will discuss this, elaborate more in details. Okay, so for this reaction, so the hydrohalogenation, so we can see the X here, which is the halogen atom here, we will only attach to carbon 2 instead of attached to the carbon 1. So the step here is trying to explain okay, why is it so? I think it's already explained by the video, so I think we do not need to elaborate further. So I think if I'm not mistaken, I think beginning of the slide for this chapter, I also see something on the carbon cation, right? You got the very first few slide, I think, on this carbon cation, the primary, secondary and tertiary, right? So as we mentioned by the video just now, the tertiary will be more stable compared to the secondary and the primary. Okay, so for this, another example given here for the hydrohalogenations of the unsymmetrical alkene governed by the Markov-Nikov rules. So just now you mentioned that under this Markov-Nikov rules saying that which one is more stable. Okay, so the primary, the major product were based on the stability. So therefore, 2-bromoprotein is more favor than the 1-bromoprotein. That is also explained why the end product you predicted is not 1 but is 2. Okay. So these are the statement for the Markov-Nikov rules. As I mentioned, actually there is one video. I will just give you the link. Probably you will listen to it when you are free. He outlined the 3 rules, but then after that he mentioned actually you no need to comply. You no need to really actually know these 3 rules, but instead of one very important one, which is talking about this carbonation, the carbonation of the stability. Okay, so this one, for example, here I think this slide also have explained very clearly on the predicted product. How do we predict the product based on this mechanism? Okay, so you have the propene here, so involve the 3 carbon. So, and then let's say you have a HBr. So what happened is the HBr, you know, this H is delta positive and the Br is have the delta negative. I think this is the, go back to your knowledge on the periodic table, group number 8, 7 valency is 7, H is valency is 1, and so on, right? So therefore, in this at the end of this product, so you would expect the Br will attach to the carbon number 2 instead of carbon number 1. Okay, as explained by the video just now lah. Okay, why it attached to the carbon number 2 due to the Br, you have 7 valency, the delta negative. Okay. Okay, so similarly with and this is also the explanation. Okay, already I think it's already the same similar one. So based on the step by step, it show outline here. How does it attack, and therefore it will not form the 1 bromo but 2 bromo. Okay, the reason why is because the carbonation is not stable compared to the secondary one. Okay. Okay, so now we so out of so many rules, about a few rules, whether you the hydrogen attached to the more hydrogen group and so on. But one of the very significant, the most important rule is you must understand this stability of the carbonation. So if you understand this, so you shouldn't have much problem to predict what is the major product. Okay, so and just we want to see here a few examples given in this slide. Okay, you have the examples of the multiplication, you have ETL and so on. You can see there are the different degree of the stability due to the different type of the carbonation. So you have 3 here because it attached to 3 different group. Okay, here you have only 1 H, so it's secondary. If attached to have 2 H here, is called primary. So the degree, the stability will increase as it change from the primary to the tertiary. Okay, so for example, another example given here is 2-pentane. Okay, what if you have a 2-pentane here, the double bond is attached to carbon number 2 and carbon number 3. So what would be the product? Okay, so from here, you have 2 possibilities. One is major product, the other one is the called minor product. Okay, so that is the possibility that could be formed if the just now, because the change is only involve 3 carbons, so there is no one couldn't be formed. Okay, but here in this case there is another possibility, but the major one would be 2. Okay, and the minor one will be 3. So what is the mechanism? I think the following slide, I think they do mention in the following slide. So we just quickly go through how we can predict here. He said that when the double bond carbon atom in the alkene have the substitution, so and one highly substituted over another, a mixture of the major product and the minor product are formed. Example, 2-methyl 2-butene. So the intermediate are secondary and the tertiary carbonation. So you can see the possibility here when there is a secondary and the tertiary carbonation, the tertiary is more stable. Okay, instead compared with the secondary. Therefore, it becomes the major. Why? Because it can form more rapidly, so it can produce more faster, okay, much faster. That's why it become a major product. So for example here, okay, it given here. So the example 2-methyl 2-butene here. So you can see the double bond here between the carbon 2 and carbon 3 here. So what happened to the HBr? So the HBr, you have one, the H delta positive and Br delta negative. So if we have it in the carbon number 2 here, you can see it's classified as secondary carbonation. So, and okay, and then you have the if the attached to the this carbon, the carbon number 3 between if you count, yeah, 3. So there is, because it already attached to another 2 group of the material here. So it's called tertiary carbonation. So you can produce a major product. So that's why we have 2 bromo, 2-methyl butane is the major product instead of 2 bromo, 3-methyl butane. Okay, due to the stability of the tertiary carbonation is greater than the secondary carboncations. So let's try it out for these 2 questions. Probably you can just try the first butane, and also the other question number 2, you try the first one, either 1-methyl cyclopentene or the 3-methyl 2-pentene. See whether you can get the answer, the predicted product or not. Yeah. So here is a summary of the one of the examples lah. So actually more or less like this is the 2-methyl pentane. Actually, I think answer one of the question. I think the you can base on this and predict. Yeah. So that is why I think it's good if you know how to draw the full structures. So when you draw the full structure, you can see very clearly whether the carbon belongs to the secondary or tertiary or primary. Okay, depends on how many H attached to the carbon.
Prof, we might give them some time to try the question, and also, well, how about we take 5 for this moment, Prof? Is that okay, Prof?
Sure. Okay, can. Yeah, can. Yeah. I think I also need to
10
drink.
minutes. Okay, I get the instruction 10 minutes. So we
Sure.
shall back
Okay.
by here
11.
11:44 or 45 like that.
Okay, sure.
Okay, so those are the main hall. Please take attend, get us break, refresh, and come back. You need to go to washroom or something. This is the time, but make sure you are not disappear. That's another thing. So I will key you again. Okay, 10 minutes. Okay. I think most of them already back to the positions, the main halls. So we will definitely we're going to continue our sessions. So are you ready? Those in the main hall. Wave your hand, raise your hand. Ready? Show some happy face. Smile. I'm going to screen capture all of you. Okay, smile again. 3, 2, 1. Okay, good. So I think the student is there already in the positions. How about the lecturers over there, the main hall? Are you ready as well, the lecturers? Okay, Prof, I get a green light. Yes, the floor is yours
Okay.
again, Prof.
Okay. Thank you.
Yeah.
But I think I lost my slide.
Okay.
How come doesn't show on here, huh?
Maybe share again, Prof. Share video.
Yeah, hold on, I couldn't see my screen now. No, I mean I want to share, but I didn't find my slide is on the WebEx here.
Okay, Prof. It's appearing.
Okay. Okay. Thank you.
Yeah, we are stopped at
Yeah,
this particular point.
just now we stop right here, right?
Yeah, Prof.
So yeah, this is the answers. Yeah, so from here, if you want to shortcut, if you cannot remember what is the rule say, one of the simple ways is you just look at the double bond here. You have a double bond between the first carbon and the second carbon. So the halogen, the I here, you will always attach to the carbon with the group, okay, with least hydrogen. The hydrogen will love to mix around with those carbon with have more hydrogen, okay. Just like the student, they love to click with those who have the same chemistry. I know now the young
Yes.
generation, they like what K-pop or whatever singer, which
Yeah.
is I do not know even one of them. So yeah, they
We are in
always
the
have
same shoe, Prof. Definitely.
so then they will like to click to those who have the same chemistry, same as hydrogen here. So his good friend is all with those hydrogen. So that is one of the simple way to remember. The richer become richer, and the H love to attach with another other friend of H also. So that is one way lah, to if you cannot remember what rule say and all the some sort like term and condition. So that is one way. So if you do not know what is carbon cation, whatever primary, secondary, probably this is one of the way for you to predict lah. It will somehow quite accurate in the sense. Okay, so and for this structure also, you can see a double bond at this ring here. So the predicted molecule will be the I attached to those carbon, especially those who have the least hydrogen. So you can see, so this is how you predict the product. So, but for a certain condition, they will have major product and the minor product. Okay, so but the major product usually it will attach to either secondary or tertiary carbonation, but it depends if you have primary, you have secondary and the tertiary, then if the tertiary will become the major product instead of the secondary, right? So this is one of the shortcut lah to predict the product, okay, if you cannot remember all the rules. So did the student got the answer right?
I think they are maybe
The
trying
student
to.
got this answer or not? The
No,
student
Prof.
got this slide. Oh, they don't have this slide. Okay.
Yeah.
Mm. Probably the student can ask further during the tutorial class, right? Because it's a big, too big crowd also is quite difficult to explain personally. But in general, if the student can understand, probably they can also wave a little bit. So if see whether majority can get the answer right or not. Yeah. Okay, can we proceed?
Yeah, Prof. Definitely, Prof.
Okay, sure.
I think if they have a question further to clarifications for this checkpoint, they might ask the lecturer during the tutorial class and also lecture time.
Okay. How I wish all my lecture got tutorial class. Okay,
Yeah.
so how about this? If the other way around, let's say you are given a starting material, okay? Ask you to what is the starting material should be used to produce 3-bromohexane. This will help you to synthesize some of the compound. Actually, I just learned from my collaborator how we can market the drugs in the shortest pathway. So where we can we go through the pattern list or what is the structure of the molecule of the drugs. For example, one of the some sort most wanted drug is like for cancer patient. So probably you can look into the structure and see how we can synthesize the same structure. So therefore we can skip the many clinical trials trials and we just go for one trial and we can push the product into market. That is one of the way that you can think of lah. So you can the younger generation probably they can look into that. It can produce many drugs not for our wealth but mainly to help the community lah. Okay, all of us will have a better health. Okay, so this is the answer how we want to predict or suggest the starting material. So since it started with the 3, so 3-bromo, so therefore the double bond here, you must start with the 3rd carbon. Okay, so in order to get the one single product, if you choose to use 2, then because of the double bond can be between 2 and 3, probably then you will have a minor product. Okay, so that is why sometimes when you do the synthesis work, we get some impurity or the side product. So we have to purify it before we can work further lah. So this is how we can suggest the starting material. So later, if you have more knowledge on this one, you can come out with the generic drugs so you can help more people. Okay, now we move on to the continue with the hydration. So for this reaction, it involves molecule, okay, H2O. So you only have H and the OH. Okay, so therefore there will be one H attached to the first carbon and another OH attached to another carbon. Okay. Okay, so what does the rule say about this? For the propane, so propane you have the first and the second carbon is the double bond. So one of it will attach to the one OH and H it will attach to one of the carbon, right? So how do you choose which one will go for it? So based on this rule saying that the OH will attach to those carbon with the least hydrogen, okay? You will prefer to those who have the group because of the stability of the carbon carbonations, okay? But the H will look for more H because H will love to click with those friends with the H, okay? So that is why the H attached to this first carbon but the OH will go for the second carbon because of the carboncation, the stability. And also one of the way, if you do not really know how to differentiate, you look for less hydrogen or have more groups, okay? Groups, either methyl, ethyl, and so on. Then there will be the possibility lah. So you can predict in such way if you forgot about those rules, okay? Okay, so now this is the mechanism that explains step by step what happened actually and why it is true and so on. Okay, so you can see from here, as we know that H2O, you have the OH, right? So you have the, and the H positive or H3O positive plus the OH. So you can see initially this carbon is called secondary carbonation because you only have one H attached here and you have another group. But this carbon, you have two hydrogen, okay? And next, what happened is the OH, okay, or you can see here, it can protonated here, it can attach to carbon number 2 instead of carbon number 1 here. And so at the end, you will produce the 2 propanol instead of 1 propanol. That is the main product. Okay, so for this one, probably you can also try to predict what would be the final product if under the hydration reactions.
Prof, can you hear me?
Yeah. Can you hear me?
Yeah, we have Prof. Just a bit stuck.
Oh, okay.
Yeah, Prof.
Yeah. Actually, I try to use my home internet. It's much faster compared to the campus one. If I'm in the office, I'm afraid you will get a lot of hiccup.
Yes, Prof.
Yeah. Okay, so this is the predicted product or expected product based on the rules that we mentioned about the stability of the carbocations. Okay, so this is another one. Do they sit for the final exam? Do they have final exam?
Yeah, they do have a final exam, Prof. It's going to
Oh.
be scheduled on 1 month from now, roughly.
Oh, 1 month from now. Okay.
Yeah.
So is this the last or second last chapter? No.
This is the last chapter, Prof.
Last chapters, huh?
Yeah, we put
Okay.
the organic as a very last chapter. So with the and this definitely those organic is carry a higher weightage, a bigger weightage during the final examination.
I see. Okay. Then it should be taught first as a first chapter so that they have more time to do revision.
Yeah, but first chapter, Prof, actually not included in the final exam. We do it in that case. Yeah, Prof.
Okay. So let them relax first, huh?
Yes, Prof.
Okay. So I just proceed, huh? Okay.
Yes,
So
sure,
this,
Prof.
yeah. So these are the few rules that actually we have mentioned just now. Okay. And we always the one that especially the hydrogen rich get the hydrogen richer. Okay, that is the rules. But actually, we do not, how to say, how about if, let's say if a structure or the molecule doesn't involve any hydrogen at all. So how then we predict the product, you see? So that we may, if we apply all these rules, we may, how to say, we couldn't predict the product if the starting material or the molecule doesn't involve any hydrogen group. Okay, so here I have, I hope you can see the link, or if not, you just type, probably Google, you can get the video lah, okay? So here in this video, it explains very clearly all the method 1, 2, 3, but however, if you not necessary to follow these 3, you just need to remember the carboncations, the secondary, primary, and so on, in terms of the stability of the carboncation, then you can, how to say, answer or predict the end product. Okay, so, and then how do we prove, okay, there is a certain test. For example, after you want to prove what is it alkene or not, you know, so there are few tests actually we can, how to say, to try to prove whether the chemicals given it is alkene or not. So one of the very easiest way, I think in the secondary school, they did this experiment quite frequent, right? So they just add the bromine and then it become colorless. Okay, so then it can proven it is an alkene. Oh, another test also can, usually you can react with the potassium manganate 7, right? So you can also to predict whether it is the chemical given is alkene or not. I think I understand that now currently the SPM, they are required to perform the experiment during our time, okay? During my generation also, we required to sit for the practical exam during the SPM. I think now they try to bring back that in order to ensure the student master some skill. I have taught some of the how to say, adult degree course in education, the school teachers, they come back to take degree in education. I was really surprised some of the school teacher not even know what is conical flask, you know, what is, you know, beaker, and how do you expect the school children would know if the teacher do not know? They can't even name the apparatus. Simple apparatus, they do not know the name. They know the glassware, but they do not know. When you ask them to name, they do not know how to name it. So, and then I also, when I was just joined UiTM the time, I was given Prof Science courses, the student, when I asked them, they said they never touched any glassware before, never performed any practical during Form 4, Form 5. So then how will we expect the student have the, how to say, interested in science? They not even touched the glassware before. Okay.
And one thing that the student also always have a mindset that the chemistry is it cannot be imaging, multi-imaginations. We cannot look at the atom or molecule. That might be a concern as well.
Yeah, that's why I always stress that actually we are always dealing with chemistry. Okay, just like even I always ask my student, when you cook, for example, now Raya kan, you cook curry. So if you cook, you want to cook faster in shorter time to be cooked. So what do? So you try to cut the meat in the smaller pieces. Why? Based on our chemistry knowledge, right? So because you have the what? The total surface area, you know, so you can be cooked faster and so on. Why do you need to have a fridge to store up to preserve your thing to storage so that you can keep longer? All this involve chemistry actually. Everything that we do in our daily life actually involve chemistry. That's why it's good to acquire some basic chemistry knowledge. You can be a better homemaker. You can be better, you know, teacher and so on, you know. So That is why we need to learn a little bit of chemistry. Okay, so back to this test. So we always have to prove, right? So in many times, so we have to prove ourselves. We have to, so this, the alkene also, we need to prove. For example, you have done something. So for example, like now people are working on the activated carbon. So how do you prove actually what you produce is the actual product that you want to produce? So this is how we can test. Okay, so just now we mentioned about using the bromine. So we also can use another chemicals, like for example potassium manganate 7, to prove actually the chemical given is alkene, belongs to alkene. So how do you know? From the observation, from the color changes. Okay, so this is another. Okay, I think there's okay, another one would be on using the acidified potassium manganate 7. So through the oxidation process. Also is another way to prove the test for the alkene. So here I think the slide have been outlined very clearly what would be the product. Okay, so I think no need to elaborate further lah. Okay, similarly to this one, it just elaborate what happened during the process. Okay, and that is why you have the color changes and so on. Okay, so this is another question to test whether what happened if you add this reagent. Okay, actually is what we have discussed just now lah. So you want to try or?
Maybe we give them a minute to try, Prof.
Yeah, yes. So the product will be slightly different if using the alkaline potassium manganate 7 or the acidified manganate 7.
I think yes, Prof. We proceed.
Yeah. So this is the answer lah, the predicted product. If you refer back to your notes, you should be able to answer that. It's quite similar, yeah. I think with that, I just summarize it. So probably the student also, you can actually get it from internet or you can draw on your own. The reason why you need to handwritten for the mind mapping is because as you write, you can memorize better. Okay. If you just listen, probably at the end of these lectures, you only grab about 20 to 30%. But if you go back and go through the lecture notes and try to write it down, make your own short notes or summary, then you can remember 50%. Okay. And then after that, you try to work on the tutorial and trying to use the knowledge that you have acquired to apply on the question, then probably you can get about 70 to 80%. So by then you should be able to score in your final exam. So that's all for me. Yeah.
Okay. Thank you so much for the. I think I have an audio problem at the moment. Just a moment, Prof.
Sure. Yeah.
Okay, I think the can you hear me, Prof?
Yeah, I can hear you.
Okay,
Yeah.
now I think yes, I've solved the problem, managed to solve the problem. So yes, before we really end our session, Prof, I would like to share the attendance. The most of the student over here, they also wish to have their attendance. They need to scan the QR code.
I
Get
see.
ready. We need to scan the QR code for the attendance. Let me share the moments. Yes, a moment. I'm looking forward. Okay, yeah. Yeah, this will be the QR code for attendance purpose. Kindly, those are in the main hall, please scan your the QR code and fill in the informations for your attendance. Meanwhile, our students are filling up the information. Again, Prof, I feel today, thank you so much for your kind sharing on this particular topic. We are that really have got a lot of information that we get it, and also a few things that we learn, especially for the I'd say the richer getting richer. Those are the things that we would like to have, because the student will have a more interactive to learn chemistry. Because why we are inviting lecturers and outside the professors to give the lecture, in order to expose the student with the new culture, or maybe the environments of study and the technique or the memorizing method and everything. And of course, a student might be in general, I'm talking about in general, always have a mind setting that the organic chemistry a bit difficult to learn, and all the mechanism and also about the memorizations of organic chemistry is quite boring. Those are the things, that stigma or perspective that we like to change. So by exposing this kind of a plenary lecture or inviting professors lectures, it's actually a good opportunity for our student, especially a very good platform to get the student ready for the next level of the study, which is very soon. Our foundation student will enter a degree level. Definitely, it is a very challenging part as well.
And I would like to quote back to what you have mentioned by Prof just now. Yes, our Malaysia need a lot of scientists. We are far from the 60% that been targeted by the Malaysia government. So this is your opportunity. Please remain in our field of STEM, science and technology, mathematics and everything, because you are the one are going to replace all the older generations. Definitely we are looking forward. Our new generation will come out with a much creative and definitely with a more innovative way to our contribute to our country, in especially in the innovation, R&D, and in the science and technology part especially. So again, Prof, I'm represent the UiTM campus foundation, campus science, foundation of science, representing the Dengkil. Would like to say thank you again for your time spent with us, and really appreciate. And before we really go on to wrap up the session again, I would like to take a screen capture our lovely picture for our, definitely we are going to put it in our social media. So again, get ready, the one in the main hall. And Prof, I'll take it in the count of 3, 2, 1. Again, another, dekat depan tu ada love dah ya. Okay, 3, 2, 1. Okay, that's a very good. Again, Prof, any last word before we end the session?
Yeah, thank you very much to your kind attention. I hope you learned something. You are most welcome to contact me. You can Google my name, or you can get my from the staff directory, also got my contact if you couldn't get hold of me. I wish all the best to the student. Look forward you were flying high, and also to bring UiTM name in the global map. And also I hope it's not too late for me to wish you Selamat Hari Raya for those celebrating Hari Raya, and also wish you all the best for your coming final exam. Yeah, with that, I thank you very much. I hope to see more of you to continue the journey in the S&T program. Yeah, thank you.
Thank you so much. Thank you so much again to all the audience and the Prof. With that, we end our session for today. Thank you. Bye-bye.
Bye.
Yeah. Okay, Prof. Thank
Yeah,
you.
okay.
The main hall, you can stop the sharing.